Good morning, everybody. What we're going to be doing is, remember, this is the hard stop, the extreme position for the handlebars. Hard stops on this post and the post on the other side. This one got damaged in the crash. It's cracked and bent to hell. It's also rusted from just being out for a while. So we're going to grind that away, get all the rust out, heat this up, bend this back, and see if we can just braze that shut. I wish I had a welder because I would just tack weld that. I don't have one, so we're going to deal with what we got. Dangerous bit is there's some seals here. Those will most likely get melted in the process. I'm going to try and put a heat shield on that. Heat conduction is just going to conduct straight through that into this piece, so I'm going to try not melting those, but most likely need to replace them after I melt them to crap. But so the grinding is done. The crack actually went a lot deeper than I was expecting it to, so I had to cut a lot further down. There's enough there to bend back, and we'll see what happens. So just got done with the brazing, but definitely just roasted the rubber seals. Once this cools off and I can actually handle it, I'll go ahead and file those down and get that flat back on there, because on the original, that was a machine surface that was completely flat and then painted over. I'm not going to go to that level. It's definitely just going to be flattened but not machined. I don't think it's necessary anyway. Here's the braze after filing and sanding it down. I mean, you know, pretty good. That's the bronze there. That's really going to take the load that I'm expecting it to take. Looks pretty good. I'm going to go ahead and mask this up, get a spray of primer on it just so that I don't get any more rust on it. One thing I should have done, which I didn't do, is this little oil seal down for, you know, it was on the inside there. I should have taken that off. This is what I was trying to protect, but completely just roasted it. So I looked it up. This is like $5. But the annoying part is I gotta go get it. So I'm gonna go stop by the Kawasaki dealer, see if they have it in stock. But for now, mask, paint, and wrap up. Super solid. Yeah, I mean, you can clearly tell that it was painted. And over here, this is that place for the oil seal. I'm gonna have to wait a couple more days. I think it's getting delivered in 2 days. Just that oil seal. As soon as we put that back in, we can just reassemble the whole front end. Which means, actually, all of the mechanical steering components that were broken are done. They're just waiting for reassembly. I didn't have a spanner wrench when I took this off originally. I just used a punch and a hammer, which works. I mean, there's nothing wrong with it. I want to be, you know, a little bit more careful with it, and I actually want to torque this down to a certain spec. I don't have a spanner wrench, and I don't have a torque setup for that, but check this out. This is a just quick CAD design that takes the spanner nut and adapts it to a 3/8 inch socket drive. Looking back at it, I probably should have gone 1/2 inch. We're going to just try this out. This was printed on one of the Markforged's plastic filament extruding printers. It's their base model. For us, all it prints is either nylon or chopped carbon fiber nylon. It's not the continuous fiber. Those are like 20 grand starting, and this one is $3,500. It's very similar. Actually, it's the same price as the Ultimaker 3. This is a nylon base. I believe it's a nylon 6 or nylon 12, filled with a chopped carbon fiber. Now, you're not getting the full strength of the continuous fibers running through any of the part, but you're getting thermal stability, you're getting some dimensional stability during printing, and you are also getting some stiffness from the chopped fibers. Now, I would not consider this a carbon fiber part. Sure, there are some properties, but each of the little pieces of chopped fiber that's in here are on the scale of a millimeter or below, and so carbon fiber is so strong. When you hear these carbon, air quotes, when you hear about carbon fiber parts for automotive or aerospace and all that stuff, they're talking about continuous fiber lengths, and so you're getting your strength of a large fiber length of greater than 100 millimeters inside of a matrix, and so you're loading the fibers in tension. And here, because the fibers are so small, loading them in tension is really difficult, and they're actually, the tensile strength increases with the critical length of the fiber. Here, it's sub-millimeter, so you're not really getting that strength, but you are still getting some of the thermal and stiffness characteristics that you would in a carbon fiber part. So I would technically call this a nylon-based matrix with chopped carbon fiber, or to say it is a nylon with a carbon fiber additive. Now, I got this just torque wrench. It's got a 1/2-inch drive. This is what I was saying. I wish I had installed a 1/2-inch drive and then reduced it down. The reason being, I want as much surface contact as possible. 1/2-inch drive would have given me a bigger surface area. But 1/2-inch drive, 1/2-inch to 3/8 adapter. This will just attach there. This guy caps there. Now I can fully drive that in and actually have a decent torque spec on it, which is, I'm super pumped to try out. So let's get started packing the bearings, try this guy out. So I was working on the top cup. Of course, I dropped one bearing right before installing everything. I put the spanner nut in there just to hold everything together, and I actually found it, but in the worst spot. Come on, buddy. Come on out. Yeah, that didn't work. Alright. Nope, that's a tiny spot. Oh, come on. Come on, buddy. Nope, that's too big. Just fall on the ground. Oh god. There it is. Stupid. Well, then let's see if that survives the 35. If it does, great. If it doesn't, we'll figure something out.
Alright. Yeah, so I got it set. Let's try this out. So, I got the initial turns going.
You can see the adapter is actually rotating. Let's see if I can. Yep, it's jammed in there, but you can see where it's rounded already. Now this is like 20% infill. I could have gotten solid with that little bit there, but I didn't really want to deal with that. So what I'm going to try is actually just putting a little shim metal stock there to sort of spread the load. Nylon's pretty, it's tough, but it is ductile. And so I want to increase the load-bearing surface, and so let me see what I have around. Alright, so I took a piece of this strapping material, metal strapping band, and just cut a small piece. It's going to fit in there, and hopefully that spreads the load out a little bit, so let's give that a shot. It's actually, so, well, you can see what happened. It's actually rolling the flat piece of metal into something that's more circular, and this is becoming more and more circular. I'm not sure what to do yet, but we're gonna try something else. Alright, I don't want to go reprint this part right now, or redesign it. I kind of want to get this assembled for the day. I will revisit this with a better design, probably on a later date, but I want to get everything assembled, so for now, I'm just grabbing the biggest wrench I have and just holding on to the outside there. So let's try that out. Alright, so that actually worked pretty well. What I'm impressed by is the fact that what I thought was going to fail, the teeth on the inside that's holding on to the spanner nut, those didn't shear off at all. I mean, there's no damage to the side whatsoever. I think just because it's a closer fit. You have a circumferential band here. These, as they print, are perimeter walls, so the perimeters are going to be a lot more solid than the infill layers, whereas here, there's just a few perimeters with mostly infill. But if you look at the outside, the part that I was grabbing onto, you can see, actually, you can't really even see the jaw impressions of the pipe wrench. There's a little bit of rust from just the tool being a little rusty. But I was able to torque it down. I don't know what my torque spec is right now, but it's installed. This didn't fail. I didn't even anticipate this guy failing up top. But I'll have to rethink that. It's done its job. Basic assembly is done. If anyone's ever curious as to how many ways you can install a front tire, turns out there are 3 wrong ways, and I found all of them. Plan it out. Pay attention. Oh yeah, there we go. I can already see. This is just, everything's loose right now, so I just still need to tighten everything up. Front wheel aligned with the steering right in the center. So I'm going to tighten everything up, and it should be rideable. Except for, all the lights hanging off and the coolant not being mounted correctly. I should probably fix that. Other than that, that's a wrap. Front end, done.